Welcome to this new activity which is about optimization. So here we're gonna determine the intervals where f is increasing and the intervals where f is decreasing and find the local maxima and minima of f for each of these functions. So let's start with the first one, which is a polynomial function. F of x equals 3x to the power of 5 minus 5x to the power of 4. The first step when you are dealing with a function is to determine its domain. It's a polynomial function, therefore its domain is R. So it's defined everywhere, okay? And then we're gonna find the critical points. So f prime of x equals, here we're gonna apply the power rule, so it's 15 x to the power of 4 minus 20 x cubed, okay? We are applying the power rule to get the derivative. Now we'll try to find the sign of f prime to determine the intervals on which f is increasing and the intervals on which f is decreasing. So here we can put 5x cubed as a factor here, and we're going to obtain 3x minus 4. Okay? Now we solve f prime of x equals 0 to determine its sign. F prime of x equals 0 means 5x cubed equals 0 or 3x minus 4 equals 0, which gives x equals 0 or, so the two solutions are x equals 0 or x equals 4 over 3. Now we're going to draw a table, a sign chart for f prime and for f. The function is defined everywhere, so it starts at negative infinity and stops at infinity. Okay, we have 2 points where f prime is 0, 0 and 4 over 3. So we're going to determine the sign of f prime. Here f prime is 0 and here f prime is also 0. Now we take a test point between negative infinity and 0. For example, you can take the negative 1. 5 times negative 1 cubed will be equal to negative 1, which is negative. Negative 1 times 3, negative 3, minus 4, negative 7. So negative times negative. So f prime is positive here, okay? You take a point between 0 and 4 over 3, for example, 1. 1 cubed will be positive. 1 times 3, 3 minus 4, negative 1. So positive times negative, it's negative. And here, from 4 over 3 to infinity, you can take 2, for example, as a test point. 2 cubed is positive. 2 times 3 is 6. 6 minus 4 is 2. So positive times positive, it's positive. Then the function f will be increasing, decreasing, and then increasing. Okay? So increasing, decreasing, and increasing. Okay? We're going to say that f is decreasing on the interval 0, 4 over 3. F is increasing on the intervals negative infinity 0 and 4 over 3 infinity. Okay? Now we're going to determine or find the local extrema. You see that at 0 here, we have a local extrema since before 0, f is increasing, and then after 0, it's decreasing. So we have a local maximum at 0. Local maximum at x equals 0. And we have a local minimum at 4 over 3. Local minimum at x equals 4 over 3. So we are done with this first function. Let's move to the second one, which is a rational function. So first of all, the domain. The domain here is R except the point x equals 3. Since this point makes the denominator equals 0, so it's forbidden. Now we compute f prime of x using the quotient rule. So u over v prime u prime v minus u v prime over v squared. So it's equal to x minus 3 minus x plus 3, since the derivatives of x plus 3 and x minus 3 are 1. So it's simple, over x minus 3 squared. Of course, we're going to remove the brackets and simplify. So x minus 3 minus x minus 3 over x minus 3 squared. So it's equal to negative 6 over x minus 3 squared. And this quantity is always negative. So we found that f prime is always negative. Since f prime is always negative, therefore f will be decreasing over its domain. So f is decreasing on, we're going to use interval notation, so negative infinity 3 and 3 infinity. So there is no interval on which f is increasing. It's always decreasing. And if you draw your sign chart, you can draw it here just to see it clearly. So f prime, it's from negative infinity to infinity. You can draw, you put the 3 here. It's not defined at 3, so I will put a double vertical line here, which means that f prime and f are not defined there. It's always negative, so you can see that f will be decreasing and then decreasing. Since the f is always decreasing, there is no local extrema for f, okay? So no local extrema. The sign chart here is optional, just to see how the function behaves on its domain, okay? So no local extrema. We can move to the next one, which is f of x equals 1 minus exponential x squared. Be careful, the square is on x here. So the domain is R, since the exponential is defined everywhere, so we have no restriction here. Okay? Now, what is f prime of x? We compute f prime of x using the exponential of a function rule. Exponential u prime is u prime exponential u. The derivative of 1 is 0, so we keep the negative sign. The derivative of x squared is 2x, exponential x squared. So this is f prime of x. Now, how to determine the sign of f prime? Just, you have to know that this exponential is always positive. So the sign of f prime will be the sign of negative 2x. It means f prime will inherit its sign from x. And we know that x changes sign at 0. So we're going to draw the sign chart, okay, from negative infinity to infinity. The sign of x will change at 0. So let's put the 0. The function f prime will be 0 at 0, okay? Now, when x is negative, it means between negative infinity and 0, the negative to x will be positive. So positive times positive, it gives positive. And when x is positive, of course, negative to x is negative, times positive, it gives negative. So what happens for f? It's increasing here and then decreasing from 0 to infinity. So we're going to say that f is decreasing on 0 infinity, and f is increasing on negative infinity 0. We can see clearly that we have a local extrema at x equals 0. So we have a local maximum at x equals 0. We are done with this function. Let's move to the next one. The last one is f of x equals negative 4 plus 2 ln of x. We know that ln of x is defined only for positive numbers, so the domain here is 0 infinity. We will not work on the whole set of real numbers, but we're gonna work only on 0, infinity. Okay? Now we compute f prime of x. Super easy. The derivative of negative 4 is 0, and we have 2 times the derivative of ln of x, which is 1 over x. So f prime of x is equal to 2 over x. Now, this function is not defined at 0, which is also a point where f is not defined. So there is no point where f is defined and f prime is not defined. Now, is there a point where f prime is equal to 0? Of course, no. Okay? Since this 2 over x is always greater than 0 on the domain which is 0, infinity. X positive, 2 over x is positive. Now, we know that f prime is always positive. Here we pay attention, we have to put a double vertical line on 0, okay? Because the function and its derivative are not defined there. So we start at 0, we go to infinity, f prime is always positive, which means that the function f is always increasing over this interval, and therefore there is no local extreme. So I'm going to say that f is increasing on its domain, which is on 0, infinity, and of course there is no local extrema since there is no critical point, okay? No local extreme. Okay? We are done with this activity. See you in the next videos.